going to write start on the chat or in the chat box. Okay, you guys, so welcome to almost our close to our last week. We still have 2 more weeks, and then we have Thanksgiving in the US, or the people in the US have Thanksgiving. And then the following week, the first week of December, we will have the Q&A with Klaus Wilke, which is the author of the data visualization book that we're reading. So I will ask you all to start thinking about questions for that day. I think that either next week or the following week, I'm gonna share I'll ask John if he can give us like a tab on the sign up Google Docs document or Google Sheets document so that we can add the questions there and everybody can see them. So I think that that would be good in case we can have at least 5 to begin with. And then, during the talk or during the Q&A, we can also ask more questions that pop into our minds that day. So I think that that's actually gonna be super cool. So now let me share yeah, I think I'm here. Okay, let's close this. Okay. So let me see what you guys are seeing. Well, anyway, I hope you can see the Google Doc that I have here.
Yep.
And here you can see that. So today I'm going to present chapters 24 and 25. Next week, we have to go through 26 and 27. And then the following week before Thanksgiving, we go through chapter 28 and 29. So next week is still available for anybody if they want to sign up. And then the following two. This 3D chapter, it's a bit longer, not much longer, but definitely longer than the ones that we're gonna cover today. And it has a bunch of tips and tricks on how to go from 3D to 2D and to really think about, is this really necessary to visualize in 3D, or is maybe better going 2D? And then the other one is understanding the most commonly used image file formats. So that's like TIFF, JPEG, PNG, and all of those. So I think that that's gonna be interesting to know. I think this one is rather short, and I can also share. I have like a snippet of a book that I read about also data visualization, but not necessarily it's more like how to do presentations, scientific presentations, including data visualization. And they have a good table where they explain what TIFF is, what JPEG is, all those file formats. And I think I can put that on the chat so that we can have that resource too. So anyway, this is what we have. Oh, thank you, Arthur. So this is what we have coming up in the next couple of weeks. So today we're gonna go through chapters 24 and 25. They're super short. So yeah, we might be here 50 minutes. So yeah, I didn't have time to prepare slides, so I apologize in advance. But again, these 2 chapters are very, very small, and they're more like tips and tricks to think about. So let's begin. So again, just to put people in context, we are reading the books Fundamentals of Data Visualization by Klaus Wilke. My name is Gabby, and I am going to, first of all, change my name because I hate it that it always shows my full name. And we are going to cover today chapter 24. So this chapter is named or is titled Use Larger Axis Labels. So essentially what we are seeing here is every time we do a graph or a visualization, we always start thinking about, or at least we have covered this in previous chapters about how the data points will look like, the colors, the grid lines, all of that. What we haven't really talked about is how important it is to have the font size on the axis, names, the values on the axis, and the legend. And even if you put text inside the graph, it has to be big enough so that it is readable by whoever is reading this graph. So if you have it on a presentation, you have to bear in mind that sometimes when you render your graph in R, Python, or whatever it is that you use, the default is going to be, or is going to look exactly like this one. That doesn't always translate good if you're talking about like a presentation, and definitely not if you're going to put this in some sort of publication. So you have to always be mindful of playing with the font size for not just the numbers on your axis, but the text and the legend. So for example, if we go to this figure, even though the text size or the font size is a little larger, is still not large enough. So think about if you're going to put this in a publication, you have to think about how this graph is going to look like in like maybe a 2 by 2 inches little frame, because it's not going to occupy the entire screen. If you're going to have it printed, so you have to think about like a sheet of paper and how this is just going to cover like maybe 1/4 of maybe not even 1/4, maybe 1/6 of your page. So the author recommends thinking about how this would look like in a 2 by 2 inches square. So here the other thing that is not such a good idea is that even if you have larger font size, when you look at your data points, they look too small. So that's another thing to consider when we're talking about font size. Also consider the size of your points, because if we're gonna print this or put it in like a report or a scientific publication, these points are gonna be too tiny to even differentiate, for example, diamonds from triangles. So that's something else to consider. Make everything as big as possible with the space that you have. So this is a better example where you have things much more well balanced. This is how he mentions this or refers to this when you have your data points also have a larger, it's not a font size, right? But a larger size. And then all the letters are much more readable. However, you have to also take into account the fact that you can always go too big. And then if you're going to have this for example, on a screen and you're going to do a publication or you're doing a report or something like that, then the problem with this is that it looks too cluttered, especially when all the text that you have here is too big and your data points are not. So they need to fit together. All the elements of your data have to be able to fit together and have like a balance. So this one right here is the one that he recommends because right now it looks huge for a screen. So then you might want to make the text a little smaller. But if this is going to go on print or like a printed report, or again, a scientific publication, this will be scaled down to 2 by 2 inches. So then it's not going to look as big as it looks right now on the screen. One tip that he gives is to, when you have this and you know that this is going to go on like a report or scientific publication and it's not going to be necessarily projected on a screen, what you can do is actually zoom in or out of the text on your screen in order to make it 2 inches or 4 inches by 4, however big the space that you want to put it in is. And that way you can also like understand and see if it's readable, if all the points and the text look balanced. So that's another thing to remember. Also, something else, and this is why they put this in like an information box, is that like R has it. I mean, ggplot has it, but there are others that also other packages, and I'm pretty sure Python will have that too, that have this option or this argument that is called scale. So when you are exporting the graph, you can also say if it's gonna be like a scale 1, then that means that exactly how it looks like here, it's gonna be exported too. Because remember, when we export this, and I think that that should be either another chapter or part of this chapter. This is something that I feel like he should have addressed. But when we have it here on the screen, let me see. So right now, this looks like, at least for me, this graph looks like it's like kind of like 5 by 3, at least on my screen. But when I export it, I'm gonna say, oh, I want this to be 12. Well, maybe not 12, but I want it to be like a 8 by 6 or something like that, or 8 by 8 if I want it to be super squared. I am going to include that in the export function, right? Like once I get it out in ggplot or whatever package I use to export it as a JPEG, PNG, or whatever. And one of the other arguments that these functions have, in addition to just say the size that I want for my graph, is the scale. So that scale is also going to control the higher the number, then it's like you're going to zoom in on all the elements. And if you go lower than 1, then it's like all the elements here um, become smaller. That's how that works. I wish he would have included that here because the scaling of images when you're exporting them, it's super important. That one is covered if anybody's interested. That one is covered in the ggplot book. Um, so in case anybody wants that. Okay, let me see the chat. I've never used that. I always like export it like with a function and then just say the size that I want. So I've never done that. That would be interesting to find out more about.
Or I wonder too, like if yeah, this is something honestly I would love to see a long form article on, because I feel like I always get this wrong. Is how to kind of ensure that your plot is going to be, well, how to put it, that you're not going to find any surprises in the output. But I guess you're saying here, Gabby, that there's ample explanation in the ggplot2 book.
Yeah, I don't remember exactly where, but I think it's in whenever they talk about exporting. I'm gonna let me think. Yeah, because
Because
it's
I
not
think
gonna be like the
camcorder,
same.
like basically you fix dimensions and sort of like the viewer in our studio accommodates those dimensions so that you can see what your plot looks like rather than having to do gg save constantly and look at the output file, if that makes sense.
Yeah. I've never used it because I know that camcorder, what it does is like it records your screen. So it's like a screen grabber, but I've never used it. So yeah, I think we need to, maybe we can ask him in one of maybe someone can write a question for the Q&A and maybe we can pick his brain, I mean, Klaus's brain on the scaling situation. Because I'm pretty sure it is, if it's not in this, I'm pretty sure it is, but if it's not in the ggplot book, then it's in the basic R book. What is it called? R for data science or something like that. I think that one also maybe that covers this exporting situation and the scale down. But I'm gonna go through them and then put something on the Slack channel because I need to just remember where it is. But yeah, I think that that part is always like, a little weird. Nobody really talks a lot about that exporting situation. Anyway, so that's chapter 24. Let's go to chapter 25. So this one is interesting, but again, it's just very short. So here, the chapter is called Avoid Line Drawings. So what the author is going to talk about, or what he talks about, is the fact that when you have a graph, it's better to use solid color as opposed to to just lines and then leaving empty spaces or the same color as the background, I guess. This creates too much clutter, like visual clutter. And once you're trying to see if this line belongs to this bar, or is it this one, or is this the bar that I'm trying to look at, it's too difficult to differentiate the background from the inside of in this case, of the bars. But this could also be like a circle, this could also be like a little triangle, whatever it is, there is not enough contrast, and then sort of your eye sort of gets lost. So when you use solid color, like in this case, it's so much more evident that whatever is in blue is inside the graph. And these white lines that are going to be in the middle of this, of the bars in this histogram, they are just divisions. So that is, I guess, with the histogram is very easy to see. But when we talk about lines like this one, like this is a density plot, and what you are supposed to focus on is the area underneath the line. And again, when you have a solid line, it kind of easier to see it. But then when you're comparing several groups here, and then you have like dotted lines in different patterns, but at least they're dotted, not solid line. Again, it becomes like, is this part of my graph or is this outside the graph? Wait, no, this is part of the other one. What am I looking at? So there is not enough differentiation between the background and the inside of each one of the density plots, or inside of each one of the density lines. So he recommends here to not just go with color, because again, white and white, white inside and white outside, you get lost. But when you do have it with color, then it's super easy to see, oh well, white outside, color inside. And if you have overlapping areas, then what he recommends is to always use what do you call it? Like sort of like see-through colors, so that it's not a solid color that is going to prevent you from seeing where the other graph begins. So this is what he recommends to do. So this is again solid color, but sort of like transparent, or I forget the name of that, what that's called. But anyway,
Alpha?
yeah, the alpha, thank you. And then the alpha, you have to set the alpha to, so the alpha goes from 0 to 1, at least in R. The alpha controls the transparency of your color. The closer to 1, the darker it is. So 1 is going to be solid color. And then the lower the number, the more transparent it becomes. So then we can also see that with scatter plots. So way back in the days when you had to pay for color whenever you were printing something like a scientific paper or even a report, or you just had access to those plotting printers and you couldn't print in color, then this is when like these different sort of shapes started to appear in graphs. But the problem again is that because there is not a solid color inside, you sort of get lost inside this. Like, what am I looking at? Is this a point? Is this like a cross? It's really not that clear. But then you go to color, solid color, and again, this has some level of transparency. And this is a little bit better. The one thing that people say is that when you have something like this, then you can see the overlapping or the jittering between points. It's easier to see it or notice it versus when you have solid color. Um, and then this becomes so much more clear than when you use one single color. And again, the background is the same color as what's inside each one of the little shapes. Um, so he puts it exactly right here. I strongly prefer solid points over open points because the solid points have much more visual presence. So he says, or at least he uses that adjective to say that, or is it a noun? I guess, to say that it's so much more distinguishable to see that this is going to be a triangle that belongs to RWD and this is going to be a circle that belongs to FWD versus here. You're sort of like, is this a square? Is this a point? Is this a what? Right? So that's what he means by presence. Um, Again, you can also see it with box plots. Um, the background, the same color as what's inside, when you have this contrast, is so much more easy to distinguish or to sort of like see the contrast between the two. Um, what color you use, it's going to depend on your preference, your aesthetics, and all of that. I would argue that if you're going to go with alpha 1 and the full saturation of color, to be careful with that because it can also look very, what's the word I'm looking for? Um, it's just going to create too much impact, right? But if you go too light on the colors or your alpha is too low, then it's going to be the same problem that you have here. There's not enough presence from your points. Um, Let me see if there's something else that that he mentions. I think that he didn't mention it here, but he did mention it in other chapters to always have the border of your plots in a slightly darker color than the one that it's inside to sort of like delineate the beginning and the end of your plot so that it's not all. So in this case, if you see here, there's like a little border, right? The same thing happens with these points. Like each triangle, it has like a little border that is a little darker than the color that it's inside. And he also has it here, I guess, because he has gray and black. And that's it, you guys. These are the two chapters that we had to read for today. They were so small. They were so short, I guess.
For the axis, for the larger axis labels, kind of wonder if, well, maybe there's no book left, but I kind of almost feel like when would you not want to have axis labels at all, right? Because
Ah,
you still have to tilt your head to the side to read them.
mhm.
Again, to me, I would kind of want to maybe have a title and a subtitle and a lot of text before the graph that would explain what you're looking at.
I think when it's super obvious and when you don't have dimensions like here, centimeters. So if you have years, for example, and your title or your caption says um, whatever variable you have throughout the years, 2012 to 2025 or something like that, then that becomes so obvious that what you have here are years that I guess you can skip that label there. But if you have like here that it's centimeters, then you definitely maybe that's a good way of knowing that I may need a label so that it's easier to read. Other than that, I would have to think about that. The other one that I also always wonder is when to put a label on your legend. Because I sometimes think that it's redundant. Like in this case, to me, this is redundant. we already know that basketball is a sport. So then you put that one. But here, because we had in this one where we had this, maybe this, in this case, it makes sense because what is FWD, RWD? This is not like something that everybody's super familiar with. So then I would skip it when it's super obvious what you have there.
Yeah, I think you made that point in the last kind of two chapters. There's the one on the titles and captions,
Mhm.
where it's basically saying, I think it was talking about, for example, like companies, and shouldn't have companies as a like legend title because it's obvious that all the things, Facebook and Microsoft and all the rest
Yeah.
are companies. Yeah.
Yeah. I like that advice that he gave in that chapter. You're right. Yeah. And here he didn't put it for years exactly. But he did put it on the y-axis because this one is not obvious. Yeah. When in doubt, ask someone, do you understand what this is? And if they ask you, what do you have on x-axis, on the x-axis, then that's your cue to say, well, yeah, it's not obvious. All
So Gabby,
right, you
when
guys.
for the week when Klaus is coming,
Yeah.
I think you said you're gonna ask John if he could provide some mechanism for us to capture
Yeah.
questions somewhere.
I
Is that
think
is
that
that
if we
right?
could, yeah, if we could open like a new, oh, I guess I just did. Maybe we can just put it here, but I'm gonna notify John that I did this. So we can put here the questions. Oh, I don't know if I can do that. Let me see. Yeah, here questions for Klaus Wilke. So that we can put here name. Oh, I guess we can just say number for the number of question, name, and then question here. And that way we can just sort of like start writing down our questions. Here it would be like Gabby or Arthur or whatever, or anonymous if you want to remain anonymous. And then here, just type down your question. Yeah. Does that work for everyone? That way we have everything centralized, I guess.
Fine by me if it's okay with John.
Yeah, I'll ask him. Yeah, because I'm I'm messing up with his document. Yeah. Let me see if this is okay. So then yeah, if he approves it or if he says that it's okay, then we'll see that on the Slack because I'm gonna post um, the message there so that he can say, yeah, I approve it or I don't approve it. So we'll see what he says.
Has anyone used Positron for DataViz yet? I'm curious.
Mm, I haven't moved, but it's one of my December because I don't work in December. I have the whole month off. So that's one of my projects that I want to embark on. The journey through positron, or yeah, the adventure of meeting positron for the first time. Have you, Arthur? Are you starting to use positron?
No, I I'm a VS Code user currently,
Mm. Yeah,
and
yeah,
so I guess you can say I'm halfway there.
yeah.
But I mean, there are a few friction points that have kept me from using Positron. Like have tried to set up my VS Code where it's like very keyboard centric, and there's
Oh, yeah.
some nice things that exist in Positron for which I can't create a keyboard shortcut. So like let's say I open the data viewer, there's no way to dismiss it except for mousing over and clicking, which sounds like a silly thing to, yeah, a silly reason not to use something, but like I've got little points of friction like that,
Mhm.
beyond which it seems like maybe it's a more mature product than when last I tried it, but getting my IT department to install something is a thing in itself, so
Mm.
that's another reason I've held off. Yeah. But at the same
Yeah.
time, like R and VS Code, there's some rough edges and like plot visualization. You have to use an extension, and it's never been clear to me like whether it properly renders the dimensions. So, yeah.
Mm. Yeah, I wish that could be another book club that we could go through, like that documentation or something. I have some resources that other people have gave me on or have um, sent me on Blue Sky, and which is like the good version of not Twitter, but like the good social media for text, the alternative to Twitter, I suppose. But yeah, but I haven't really because I've been so busy this semester. I'm an art studio girly. Like I started using it like so many years ago, and I haven't looked back. But I am curious about positron, so yeah.
Andrew Heiss at I think that's how you pronounce his name at the University of Georgia or Georgia
Hmm.
State, I forget which one it is, has a nice series of blogs about his kind of gradual move to positron.
Ooh. Yeah, just what I would like to know is for me, for example, because I'm so comfortable using our studio, is it really worth going to to positron? Like, what am I gonna gain by switching? Because our studio is not going anywhere. At least that's what Hadley keeps saying. Our studio is not going anywhere. We're just adding more platforms to use or GUIs to use to code things, but our studio is staying. So I'm like, okay, so if it's staying, what am I gaining by using positron other than being able to use Python or different languages, Mermaid, whatever, at the same time with R? I can also do that with um with Quarto. So I'm like, why do I want to switch? That's the one question I haven't been able to answer. But regardless of that, I am curious. So yeah, we'll see if I have
Better Git integration, I think, is one of the
to.
big sell points. I mean, that's also true of VS Code. That being said, I never use the Git client within our studio. I always use the external thing until I move to VS Code where it's integrated.
Oh, you mean like using Git?
Yeah, or sort of like seeing the diffs and being able to commit. So like all the version control stuff
Ah,
um, yeah, it's a first class citizen of VS Code. I guess you can put it that way.
well,
And
I
so I
do that
think
in our studio, but if it's more efficient, yeah.
Positron being like a fork of VS Code, it kind of gets that for free.
Oh, well, I like that. Yeah, just that alone might be the selling point for me. Yeah, because I mean, I use GitHub, and I do that from our studio, and I also have like the GitHub desktop app. But if it's gonna be easier in Positron, then or to start using Git, not GitHub, but just Git. Yeah, interesting. Maybe we can also ask Klaus Wilke to see what he's using and what he recommends.
There you
Maybe that
go.
could be another question. Yeah. All right, you guys. If there are no more comments or questions, then I guess we can just stop now and reconvene next week where Arthur is gonna walk us through chapter 26 and 27, which is gonna be like the almost done with the book. So I'm excited about that. Um, So yeah, I'm gonna post the image file formats that I have, the snippet that I have on Slack too, so that we can have it. And then that's it. Have a lovely weekend, you guys, and see you next week.
Thank you, Gabby.
See you next week.
All right. Bye, guys.
Bye.